Hi guys, this is Samin. I'll be walking through discussion 5. And so let's get started with the first problem. So the purpose of the first problem essentially is to give you guys some practice applying the equations for approximate Q learning, and then also to understand the update rule and gain some intuition. So in the first two parts, A and B, will just be applying the definition of the Q value and computing some Q values given some defined features. Okay, so if you recall, in approximate Q learning, the Q value is defined as just the weighted sum of features. All features calculated for that state action tuple. And so in vector notation, we can write this as the dot product of the weight vector and that feature vector corresponding to that state action tuple. Okay, so this will give us enough to solve part A and B. So for A, they just want us to calculate the values of these two features they've defined. So feature G has to do with counting the numbers of ghosts, and then feature P has to do with the number of food pellets. Okay, so let's start with feature G. So the state action tuple is the current state and the left action. So at the current state, the value of A is the number of ghosts within one step of state S, so that's just going to be 2, plus B, the number of ghosts Pacman touches after taking the action left, so that's going to be 1, plus the number of ghosts within one step of the state that Pacman ends up in here. So we're going to count the red ghosts, which is going to be on top of Pacman, so ultimately we have 4. And then for state right, we have 2 again for the number of adjacent ghosts, and then 1 for the number of ghosts we encounter, and then 1 for the number of ghosts that are adjacent to us in the state that we end up in, which is here. So that's 4 again. And then for doing up from the state, we currently have 2 ghosts adjacent to us. We're going to encounter no ghosts after going up, and then after we go up, there will be no ghosts adjacent to us. So that's just going to be equal to 2. And then what happens when we do the action stay? So there's 2 ghosts adjacent to us, 0 that we encounter, and then 2 ghosts when 2 ghosts at the state that we end up in, which is just this current state. So that's 4 again. Okay, next for FP. So let's consider state and left again. So the number of food pellets within one step of us currently is 1, and then plus 2 times E, which is the number of food pellets eaten after taking this action, which is going to be 0 for moving left, and this is just 1. And then likewise for going right, we have 1 adjacent and then 0 consumed, and for up, we have 1 adjacent plus 1 consumed, and then for stay, we have 1 adjacent and 0 consumed. Okay, so pretty straightforward. We're going to go to part B now. So essentially, given these features, we want to calculate the Q values for each of these 4 tuples here. So let's just extend this table. Okay, so they're telling us that the weights are -10 and 100. So we calculate this Q value for state left by weighting each of these feature values by their corresponding weights. So we're going to get 4 times -10 plus 1 times 100. So that's going to give us 60. And then we're going to have the same thing for state right. So we're just going to have 60. And then we're going to have 2 times -10 plus 3 times 100, which is going to be equal to 280. And then likewise 60 again. Okay. So likewise, straightforward, just an application of this equation over here. Okay. So in the next two parts, C and D, we're going to be considering the update equation in approximate Q-learning. So recall that in approximate Q-learning, the algorithm works like this. So essentially, we're going to take a step in the environment, and we're going to receive some data. We're going to receive the state that we started in, the action we took, the state that we ended in, and then the corresponding reward. And then using that, we're going to compute a quantity called the difference. Which is defined as the reward plus the discounted version of the V value at state S prime, which can otherwise be written as a max over Q values, like so, minus Q SA. And essentially you can understand this equation as the updated Q value for SA after we've received this data here, and then this is the old value, the old Q value for SA before we receive this data. And the weight update for each weight I is just going to be the old value of the weight plus alpha, some learning rate, times this difference times the value of the ith feature corresponding to that weight. Okay, so we're going to apply this to, and by the way, you're going to basically just repeat this process. Okay, so for part C, they're telling us that we're taking up from state S and then traveling to S prime, which is just the spot above, and then receiving a reward of 250. So this is our data point that we have to work with, so basically this over here. And then they want us to calculate the new estimate of the Q value for S based on this episode. So like I said, this portion is defined as the new estimate for the Q value based on this data point that you just received. So that is, let's calculate Q new SA. So that's just equal to the reward, 250, plus the discount of 0.5 times the max over Q S prime. So when you're in S prime, the available actions we're told are down and stay. So let's calculate each of these. So we're going to be using the same formula that we use in part A and B. And so using these weights from part B. So the Q value for S prime down is going to be equal to -10 times the value for feature G, which is the number of ghosts within one step, which is 0, plus the number of ghosts Pacman touches after taking the action down from S prime. So after we take this action down, we're going to end up back here, and we're going to be touching no ghosts. And then the number of ghosts adjacent to us in our final state here, which is 2. Okay, plus 100 times the value for feature P, which is the number of food pellets within one step of the state S prime. So when we transition from S to S prime, we're going to have already consumed the food pellet. So when we're here, there's going to be 0 food pellets. So that's 0. And then the number of food pellets eaten after taking the action, there's no food pellets on the board anymore. So that's 0. And so that's going to be -20. And then we're going to do the same exact thing for Q stay. So it's -10 times the number of ghosts currently next to us in S prime, which is 0, plus the number of ghosts we'll encounter by staying, which is 0, plus the number of ghosts in where we end up after staying, which is still S prime, so 0, plus 100 times the number of pellets within one step of us, which is 0, and then the number of pellets we consume by staying, which is 0. So again, this is 0. And obviously the max of -20 and 0 is going to be 0. So this gives us that our new estimate for the Q value of state and action is going to be 250. Oh, and by the way, this action is up. Okay, great. Okay, so on to part D. So with this new estimate for the Q value and a learning rate of alpha equals 0.5, we want to update the weights for each feature. So I'm just going to do this in vector notation. So the vector version of this is simply just this update. So let's just perform the weight update. So it's going to be equal to the old version of the weights. So let's put old weight G in the first slot and then old weight P in the second slot, plus the learning rate times the difference. So we have already calculated part of the difference, right? We've already calculated this part here in the previous part of the question. So it's going to be 250 minus the Q value of state up. And we've already calculated this too, so it's just going to be 280. So that's the difference times the feature vector. So these are each of the features for state up. So feature G for state up is 2, and then feature P for state up is 3. And so ultimately, that's going to give us, and this is 30, -40, and 55.